Okay, the next question I'm going to be dealing with is this one here. We'll call it number 2. I'll put a 2 by it there for us. It's going to be either binomial, geometric, or Poisson distributions, and we're going to be using this worksheet back here. You have this one, if I can call it up. Looks like this on binomial and geometric distributions. So let's read this question very quickly. It says 87% of the population is right-handed, and you are randomly selecting 12. What is the probability that none of them are right-handed? None of them. So that's 0. So then you'd set up your information here. I've got n is equal to 12. I've got a percentage here at 0.87, and I've got 0 as my x value. So going back quickly to this thing, I'm going to pull that down a little bit, but going back quickly to this, I'm going to use this one right here to get my probability. So on my calculator then, what I'll do here is I'll just do a binomial. So I'll jump back to that real quick. And I'm going to go second, and then vars, and then we're going to go up to a binomial, and it can be a PDF here. We don't need a CDF, so we can go that, and the number was 12, comma 0.87, comma 0, and I would expect that to be a very small value, and it is. 2.3 times 10 to the minus 11th, essentially 0. Since 87% of your population, your number's so big, you would expect that to last. So I can break that down as 2.33 times 10 to the minus 11th. So a very small value. Well, what about the next one down? Next one down says this. What is the probability that there are more than 8 right-handers? More than 8 right-handers. So I'm going to this thing right here and check that out. More than 8 would mean this one down here. X is greater than 8, so the equation is 1 minus the binomial CDF NPR. So looking at those things right there, what I'll do here is put those back into my equation, and I've got n equal to 12 still, p is equal to 87 and 0.87 I should say, and then x is now equal to 8. So I'm going to go 1 minus the binomial of that, and CDF, because it's a cumulative one, and I'll go 12 comma 0.87 comma 8 and get my answer. So throwing that in the calculator, 1 minus, oh, can't see that, so there you go, 1 minus second vars, go up to binomial CDF, and then grab that, and then it was 12 comma 0.87 comma and then 8, and then parentheses. And let's see what we get. About 94%. So the probability that 8 or more would be greater than, or to be right-handed is 84%, which seems about right, I suppose. So we'll put that 94%, 94%, I'm sorry, 94% or 0.94, whatever it is there. And that's how you do the first part of problem number 2, and I'm going to save this one off and take care of it that way. And then we'll go on to number 3, which is this one right down here with type of blood.